Hello all, myself Devendra Itole, working as assistant professor in ENTC Engineering Department from AISSMS Institute of Information Technology, Pune. Today's topic is LCD interfacing with 8051. In this video, we are going to study pin diagram of LCD, its command codes, and how to interface LCD with 8051. Liquid crystal display are widely used because of its low current consumption as compared to SSD. Most common LCD connected to 8051 are 16:2 and 20:2 displays. LCD uses 5:7 dot matrix to display any character. LCD generally use a common control chip, Hitachi 44780U, and common connector interface. LCD range in size from 8 characters to 80 characters, ease of programming for characters and graphics. LCD has total 16 pins named as VSS, ground pin, VCC, power to LCD. It requires a plus 5 volt supply. VE used for the contrast adjustment pin. RS, which is a register select. There are two very important registers inside LCD. RS pin is used for their selection. If RS equals to 0, the instruction command code register is selected, allowing the user to send a command such as clear display, cursor at home, shift display left, shift display right, etc. And if RS equals to 1, the data register is selected, allowing the user to send data to be displayed on the LCD. R by W means read write mode. This read write input allows the user to write information to the LCD or read information from the LCD. R by W equals to 1 used as a read mode, and when R by W equals to 0, it will used as a write mode. EN, enable. The enable pin is used by the LCD to latch information present in to its data pins. When data is supplied to the data pins, high to low pulse must be applied to this pin in order for the LCD to latch in the data present at the data pins. Then DB0 to DB7 or D0 to D7 data pins. These 8-bit data pins D0 to D7 are used to send information to the LCD or read the contents of LCD internal registers. There are also instruction command codes that can be sent to the LCD to clear the display or force the cursor to the home position or blink the cursor, etc. LED plus and LED minus is the anode of backlight LED and cathode of backlight LED. So these are the LCD command codes. 0x30H, which means LCD selected is 8-bit mode, one line 5:7 dot matrix. If you are given a command as 0x38, it means 8-bit mode is selected, 2 line 5:7 matrix. Like this way, numbers of codes are there, like 20H, 28H, 01H means clear display screen, 02 return home, 06 increment a cursor, 08 display off cursor off, 0E display on cursor on, and so on. To display the text on the LCD, if you are using a 16:2 line, then we have to use the 0x80H, force cursor position on the first position of first line or first row, and 0xC0, force cursor position on first position of the second row. Now let us see how to write a program for LCD interfacing. This is the program of LCD interfacing with 8051. So as we know that whenever you want to start a program in assembly language, we have to use the ORG, that is origin. You have to start the origin from 000H. Then as you can see, move a comma #38 is written. When I want to write a program for LCD interfacing, first of all you have to use the command codes. First command which you have passed is 38, that is nothing but 2 lines 5x7 matrices get selected. Then 0EH, which means display on cursor blinking. 06H, which means increment the cursor, it also called as a auto increment. Cursor is auto increment from left to right. Then move A comma hash 01H, which means clear display screen, and move A comma hash 80H, which means force cursor to beginning of the first line or the first row if you are using 16:2 matrix. Okay. Here A call CMD is written, that is CMD subroutine is get called. Then move A comma hash A. Here on LCD we are going to display AISSMSIOIT. So this was the data which you want to display on the LCD. To display a character, this format you have to use. Move A comma hash in single inverted comma A. Likewise, A call text is get called. Then I S S M S, this is not written, no character is used here, we are considered as a space. Then I O I T. After each character we are using A call txt. Now let us see what is in the label CMD. As we know that when you are using the command codes, RS should be 0, R by W equals to 0, and enable high to low. These steps you have to follow when you are passing the command codes. RS equals to 0, R by W equals to 0, enable high to low. And D0 to D7. In this program, D0 to D7 is connected to port 1. So whatever is the accumulator will go to the D0 to D7, nothing but to the port 1 of the 8051. Then clear 3.0 is nothing but RS equals to 0. Clear 3.1, P 3.1 means nothing but R by W equals to 0. Set 3.2 is nothing but enable equals to 1. Then we are using the A call delay. Then clear 3.2, nothing but enable equals to 0. Then as we are using the A call instruction, we have to return back, so that's why you have to use the RET. Same for the text also we have to write, only one difference is there. Here RS equals to 1. Okay. Whatever in the A, the character which you want to display, that will move into the P1 port 1. RS equals to 1, R by W equals to 0, enable equals to 1, enable equals to 0, and return. Okay. This was the delay which you have to give to the LCD, so that whenever one command it was sent, we have to wait for some time so that we can send a second command. Same for the text also. So this was the delay in which R2, R3 and R4 registers are used. By using the DJNZ, we are given a delay. So whenever instruction is get executed, this program, first of all you have to write into the kill micro version, so that we'll check whether any error, opcode error is there or not. Yes, I have opened the kill micro version. I have copied the program and pasted here. Now to run a program, first of all I have to find out whether any error occurs or not. So I will go to the translate, then build, then rebuild. So you can observe here, no, zero error, zero warning will there. So now here hex file is generated. This hex file we have to load into the hardware. Now here we don't have the hardware. Instead of hardware we are going to use the software, the Proteus software. Now as I open the Proteus software, I already designed a circuit diagram here. You can observe port 1 is connected to D0, port P1.0 is connected to D0, P1.1 is connected to D1, P1.2 is connected to D2, D3, P1.3, like this way till P1.7, which is connected to D7. As port 3 is connected to RS, R by W enable, you can see here RS is connected to P3.0, R by W is connected to P3.1, and R by R enable is connected to P3.2. To see the output, the program which you have written, you just have to double click on this IC. Here by default 12 MHz is written. I changed to the 11.0592 MHz. Program file, initially it is blank. You have to open the folder. Wherever your hex file is get created, and my hex file is created in the objects folder. As I have given the name as lcdd.hex, project file name which I have given. I will just open it. Yes, that is get selected and click on OK. If you want to add again more LCDs, just you have to type here LCD and select any LCDs from these results. Okay. Already I selected, just I have to play now. When I play, let us see what will get output. As you can see there, we are getting the output AISSMSIOIT, which is displayed on the LCD. Remember one thing, pin diagram should be connected properly. Otherwise, though your program is correct, if the hardware pins connections is wrong, you will not get the output. Thank you.